Before we get into all the oogie calculations you need to do to find the different parts of a graph so that you can graph it using the clues, I want us to look at how to take the clues and draw the graph. So what do we know? Suppose I know that the domain is the reals. I know that the derivative is 0 at x equals 1 and 3. I know the derivative is negative over the interval 1 to 3, and it's positive over the other two intervals. F double prime is 0 at x equals 2. F double prime is positive from 2 to infinity and negative on negative infinity to 2. I like putting the information more in this kind of a graph thing, so I put it in my graph. So on top I've got information about the first derivative, and on the bottom I've got information about the second derivative. So I have 3 points that I know something about, A, B, and C. From A to B to C, my function is decreasing, so I will put my dots in a decreasing way. Before A, my function is increasing, and after C, it's increasing. So let me do a quick sketch of what that might look like. Just up, down, up. Now, the second derivative tells me about curviness. Curviness is how I'm going to connect these dots. If the second derivative is negative, we have concave down. And if the second derivative is positive, we have concave up. Concave down means it opens down, and concave up means it opens up. So let's look at another one. Suppose I know the domain is everything but 1. My x and y intercept are the same, they're both 0. I have a vertical asymptote at x equals 1. I have a horizontal asymptote at y equals 1. The first derivative is negative from negative infinity to 1 and from 1 to infinity. Remember, we have a vertical asymptote at x equals 1, so it's like we have two separate graphs almost. The second derivative is negative from negative infinity to 1, and it's positive from 1 to infinity. There are no critical points. There are no inflection points. So what does this give me? I have not much on my graph. I have one point of interest, and it's not a point, it's an asymptote. Let's see what I know. It's decreasing before and after the asymptote. It's concave down on the left and concave up on the right. There are my axes. I think I'm going to need a little bit more space. That's better. Okay, so I have my two asymptotes. I have one point that I know that I can connect to. Now the question is, how do I draw this thing? I know it's decreasing over here and it's decreasing over here. I can't go above the horizontal asymptote, because if I do, as I go out to infinity, I'll have to come back down. And that means my graph is increasing over here, and that's a no-no. I know it's decreasing everywhere. So I have to stay below the horizontal asymptote here, go through this dot, and then as you approach a vertical asymptote, you're either going to zoom up to infinity or zoom down to negative infinity. I can't zoom up because that means I'm increasing. So that means on the left side, it will look something like this. And it wasn't supposed to touch that, but kind of hard to draw on computers. Now, how do I fill in this section over here? Well, again, now I have to stay above the asymptote because I'm going to get closer and closer to it as I go out. If I go below the horizontal asymptote, I'll have to come back up to catch it. And as I get closer to the vertical, I have to go up to infinity. Can't go down because then my graph is increasing here. So that's how it looks in that section. Let's try another one. Same situation, the domain is everything but 1. I have x-intercepts at 0.75, 0 and 2.0. I have an y-intercept at 0, 3. I have the vertical asymptote again at x equal 1. I have a horizontal asymptote again at y equal 1. But I've got different information. I have a critical point here. F prime is 0 at x equals 0. It's positive on the interval from negative infinity to 0 and from 1 to infinity. And it's negative on the interval from 0 to 1. The second derivative is 0 at x equal negative 1. I have the second derivative is positive on negative infinity to negative 1, and it's negative from negative 1 to 1 and from 1 to infinity. I'm going to put that in my chart because I like it better like this. I made this line more solid just to remind us that the graph breaks there. It's two different pieces. I have it's increasing, then decreasing, then increasing in my sections. I know that I've got concave up here, concave down, concave up. So let's draw this. Okay, so I have my asymptotes. I'm going to plug in my points. There's the y-intercept I have a couple of x-intercepts. I know that at x equal -1, where is it? I'm going to have the second derivative equals 0. So that's an interesting point to me. Where do I put it? Well, I'm increasing from -infinity up to 0, which means whatever point I choose has to be below this one. So I'm going to put it there. Like before, I know as I go off to infinity, I can't go below this line because that means I would have decreased going from left to right. So I have to stay above this yellow line and slowly increase up to here. Keep increasing until I get to here, and then after this point I can decrease going through that point. So let me see if I can draw this. I had a little bit of trouble doing this when I was sketching on the computer. Yeah, that's my second attempt. The first one was crappy. Okay, so now I've got this one. Again, I know I am increasing on this whole section. I can't go above the asymptote because that means I have to come back down, and I can't decrease. As I go toward the vertical asymptote, I have to go down because I know I'm increasing the whole time. So I have that over there and that down there. So that's what that graph looks like. So think about what you know and try to make a graph that fits all the data you have. Later we will work on finding the data. After this, we will figure out how to actually find the data.